All right, so we're going to solve one of the problems, the example problems on the packet. This is in the solving systems of equations. This is the second example. Find all points of intersection of the graphs of x squared minus y equals 3 and x minus y equals 1. I wanted to do this example because it is the trickier of the two examples, and it's very similar to the types of equations you might have to solve in physics. Of course, in physics, you're not always going to have numbers, and they're definitely not going to be x's and y's, but we're going to start here with this. So in these types of systems of equations, you have two missing variables, x and y in this case, so we need two equations in order to solve. There are different methods to go about this that you would have learned in your algebra classes. I tend to use the substitution method because it's the one that just makes sense most for physics problems and generally the path that we would go to solve a physics problem, so that's what I'm going to focus on. Any equivalent methods would work. If you have a fancy like TI Inspire that has all the computer algebra stuff where it will solve systems of equations for you, don't. In physics, please don't do that because your points awarded on problems are going to be for your method. So although this is just algebra, your method of solving demonstrates an understanding because these equations in physics will represent real world phenomena, and that your methodology and the way that you solve the problem demonstrates your understanding of how those equations work. It's important that you show all of your work. I'm going to show a few more steps than I normally would on a problem because we are reviewing the algebra skills here. I will make sure to note what steps are really necessary, and I will also get tips for how you should show your work. I find that there's some students that are just really good at math, and it is painful for them to show their steps. But on an AP problem in physics or in any of my in-class tests, or as you move through higher levels of science and mathematics, you will find that your method is more important than the answer, because your answer is invalid unless your method backs it up. You have to prove that your answer is correct. In physics, that involves using physics concepts such as conservation laws, equations, and proper math. So I find that the students that really struggle with physics at the start are often the ones that either have a difficult time just with the basic math or are super good at the basic math and can arrive at a correct answer but aren't earning the points because they're not showing the method. So this is equally important for both types of students. So what I'm going to do here in this case is I'm going to go through this process. Now, because my x term over here is squared, that means that I will have two different solutions for x, and therefore two corresponding solutions to y. It's important that I find both and that I represent my answer as solution sets properly. I have different methods and ways that I could approach this. Not everybody is going to approach it the same way. In AP, if there's different methods to solve a problem, both methods, or as many methods there will equally earn points as long as your method is clearly shown. So I'm going to use the same steps that were in the packet to solve this problem. Although if I were to solve this again on my own, I might go about it in a different order. So in the packet, the first thing I did is I started with my simpler equation and I solved for one of the variables. In this case, I'm going to solve for y. So to solve for y, I'm going to add the y to the other side. So I'm going to get x is equal to 1 plus y, and then I'm going to subtract the 1 to the other side. I usually don't show these little addition and subtraction steps, but if you are the type that tends to make a sign error things, these little steps are often important. Teachers teach different ways to show work, so your work may not look the same as mine. Now, this is an intermediary step. This is a really important one because I've just found an equation for y in terms of x. So I'm going to make a note of that, and then because I'm going to substitute that into this equation, I'm going to provide a roadmap for whoever is reading my work to understand exactly what it was that I did. That is a really hard thing to learn, but if your work is chaotic and you're working in different locations and you start over here and then you jump over here, if someone is trying to look at the logic of your work, if they can't find that logic, it's likely you're not going to earn full points. So if you do work over different areas, or you run out of space, or you move somewhere else, the simplest thing to do is to provide an arrow. Or I can number it, like this is step number 1, and then I come over here, and then this is step number 2. There's different ways you can go about doing that, but make it easy for someone to read your work, because your work is your evidence. So the next thing I'm going to do is I'm going to substitute this y over here. So I'm going to get x squared minus x minus 1 is equal to 3. Now, I did something really, really important here. This is something that a lot of people skip. I showed the direct substitution of my solution. And I did that because in a lot of cases on an AP scoring guidelines, the points will be for correct substitutions. Sometimes there are no points for correct answers at all. They don't have to look at your answer, they just have to look at your work. And if you can't track the work easily because you do a lot of steps in your head, it'll be hard to earn those points if you make a mistake. So it's always a good idea to do that. Also, common mistakes are in distributed negatives, so if you show this step here, it's less likely that you're going to make that common mistake of forgetting to distribute a negative. So I'm going to distribute that negative. I'm going to get x squared minus x. Let's see, that's going to be a plus 1 is equal to 3. I am then going to move the 3 to the other side, so that way I can show that I've gotten my equation in standard form. That's me x squared minus x minus 2 is equal to 0. So this is a really important step, and this is where a lot of methods will diverge. So there's a bunch of different ways you can solve this step. You can do a factor method. You can actually factor this one pretty standard. Okay, by going through that, you could solve the quadratic equation, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. You can plug the equation into your graphing calculator and graph it and use your calculator to find the zeros. You can use a quadratic solver on your calculator. If I use a calculator to solve this equation, I'm not going to have work shown for that step. Instead, you should say, hey, I used my calculator to graph and find zeros. Make a note, because once again, you're earning points for your method. Show your method. I know it's like super annoying to have to write this down, and you've probably been fighting it for years, not believing when teachers tell you you really need to show your work. But in physics, you really need to show your work. And it's the points. You may have only 25% of points on a whole free response for an AP exam that are for correct answers. Everything else will be for steps in algebraic solutions, substitutions, explanations, and so forth. So always show your method. So I am going to show both of these methods right here, kind of side by side, because common mistakes often happen. So I have the option of having a negative and a positive here for my factor on the end, and they've changed the way they teach this a long time ago, and so I don't know the fancy grid methods that you've been taught, so I'm not going to use that. But I know that one has to be positive, one has to be negative, because I have the negative here with the 2, which tells me that I need to have one of them be negative and one of them be positive. And then because I'm negative here, that means that my factor that is larger has to be the one attached to my negative here. So 2 only has factors of 2 and 1, so that means that 2 needs to go with the negative and the 1 needs to go with the positive. When I'm working this step, the next thing I do is I show that each of those are equal to 0. This is a step that I notice a lot of people skip, but I find when people skip showing this step, there's a lot more sign errors that occur. And then people make silly assumptions when they go through this process that kind of lead to incorrect physics. So this is a really good step to show that there are 2 equal methods of arriving at a value that is equal to 0. So I will have x equals a positive 2 as a solution and x equals negative 1 as a solution. So those are my 2 possible solutions for x. Now, of course, I'm not done because I still have to find the corresponding values of y, but that's not that bad. Let's go over to our quadratic equation here just to remember what to do. And I'm doing this especially because I made a mistake when I plugged into this equation. And it's a very common mistake, so I wanted to do this again to show what silly mistake that is so you can be aware of it so you don't make it yourself. So x is equal to negative b. Well, when I look at this equation, I'm going to have my a and b and c terms. So a is going to be 1. That 1 should be over here. B is going to be a negative 1, and C is going to be a negative 2. So the mistake that I made the first time was because B is negative 1, I plugged in negative 1 here, and instead of negative 1. So it's a really good idea when you're substituting in equations to use parentheses to enclose the value that you actually substituted in, because it's less likely to cause a mistake. And then b squared be negative 1 squared minus 4, a is a positive 1, c is a negative 2, all over 2 times a is 1. So that's my equation there. When I go through to solve, I'm going to get a positive 1 plus or minus the square root of 1 plus 8 all over 2. So that's going to be 1 plus or minus the square root of 9. So that's going to be 1 plus or minus 3 over 2. So that's going to give me 2 solutions. I'm going to have a solution where x is equal to 1 plus 3, which is 4 divided by 2. And then I'm going to have a solution where I'm going to have 1 minus 3, which is negative 2 divided by 2. So it's going to be x equals negative 1. So I arrive at the same 2 solutions. Now I want you to notice something that I did here. I didn't just write random phrases down. I kept this in an equation format. So x equals this phrase, I substituted in this term right here, and I'm showing these equals. I'm not just showing them randomly around my paper side by side. I'm keeping them in a logical order. When I ran out of room, I moved to the next line, but I can still see a logical progression. When it split off into 2 different solutions, I showed that. One thing that you could do to greatly improve your success in physics is to start working on your problem solving strategies now while you're working on the summer assignment. So those are 2 different methods to show that I get my 2 solutions for x. And then I need to make sure that I find my values of y. So when x is equal to 2, I can find a value of y, and when x equals negative 1, I can find a value of y. So I'm going to use this equation right here. So y is going to equal x. Well, I'm going to actually put that right up here. So y is equal to x minus 1. I'm going to show my substitution in right here. So y is going to be x. X is 2 minus 1. So in this case, y is equal to 1. Here, when I do this, y is equal to a negative 1 minus 1. So y is equal to a negative 2. So I have 2 values for y. Now I am not done. And this is where a lot of people stop, is I haven't showed essentially my solution set. So I prefer the method that shows x equals 2 and y equals 1. And then x equals negative 1 and y equals negative 2. So that is the way that I would show my answers. I would box my answers. I always box my answers to make it easier for whoever's grading to see my answers. Because sometimes if you have your work shown, depending on the way the rubric's worded, if it just says to determine or calculate something, as long as you have work shown, they don't necessarily check every single step. If it says to derive, they are definitely checking your steps. So if I have a clearly defined answer, and I'm pretty confident that's right, and I've got work shown, if I have it well defined, they'll just look there, give you the benefit of the doubt that the work is right, and move on. Just depends on the wording of the question. What I don't want you to do, and this is the way they have you do it in math, is you do 2 comma 1 and you do like negative 1 comma negative 2. The reason you shouldn't do this is because when we're working in physics, we're not working with x and y. So if you define, hey, this is x and y, and then you do a set notation, then that's probably okay. But if I'm dealing with r and t as my variables, if I just list these here, r and t are not standardly written as x and y in a set notation like this, so I'd have to clearly state, hey, this is r and this is t. So I'd have to define that that is how I am doing my answer. So just be very, very careful with how you solve your problems. So you'll have some practice for this on the summer assignment. If you have any questions, please let me know. Have a good day.